Hello everybody and welcome back to the channel. Today we have a pretty cool video, I hope. That's actually kind of like a prequel slash setup video to hopefully a series of videos that I'll be releasing on the channel soon, which is a bit of a trip slash vacation that'll be going on with some of my friends, because of course, some of you will know I have graduated university just the other week. Well, technically, I haven't graduated yet. I finished my last term. Convocation is later, but in any case, we're going to be traveling. We're going to be going to Japan, Taiwan, Hong Kong, and also Germany for Academy 2025. So that's going to be pretty cool. And of course, one of the things you need when traveling is internet. Now, of course, I personally have a pretty decent roaming plan. For the Canadians out there, you probably know Freedom Mobile has some pretty decent roaming plans, but not everybody on the trip does. And roaming has the disadvantage of latency and your IP, because the way roaming works is all of your packets, all of your data that is roamed in the country that you're at gets tunneled or proxied back to the original country. So even though I'll be, say, physically in Japan, my IP address will be a Canadian IP, and all of my traffic will be routed to Canada. So there's a latency penalty to that, as well as I will be getting the Canadian internet and not the Japanese kind of geolocated internet. So there is some benefit to having a dedicated SIM card that you throw on your phone, or one of those sort of pocket Wi-Fi, MiFi devices. Now, of course, I could have just bought a pocket Wi-Fi slash MiFi device to share some LTE slash 5G internet with all of the people on the trip. However, that will not stand. I will not allow more proprietary hardware. Oh, I guess I say that on top of the MacBook. In any case, I will not allow more proprietary hardware to be in my possession. So instead, I built this thing that I call the FOSS Spot, and it is a pretty neat little package, as you see. It's about palm-sized, 3D printed case, and USB-C powered. It's a Raspberry Pi Zero in here with a little LTE modem, the SIM7600G-H, I believe. This thing's running OpenWRT, and it is pretty freaking cool. Now, you may be wondering why I already have it, given the fact that this is the intro of the video, and this is, supposed to be a build video. I did a pretty bad job at the intro when I started building this thing, so I decided to do the intro now. You get to look at it and how cool it is. And by the way, obviously, all of these files will... Whoops. All of these files will be available on, I'll probably upload the model to printables and any sort of configs and stuff I'll throw up on GitHub, so you can build one of these yourself. I'll walk through the software setup. But without further ado, let's warp back in time to when I originally unboxed all the parts and put this thing together. So we have here a 4G modem that we're going to be able to use with a Raspberry Pi 02W. And also, I don't have it yet, but some sort of USB Wi-Fi implement. We got some adapters, and hopefully, and also 3D printed case, revision 1. The idea is we're going to be putting together a Wi-Fi hotspot powered by, a Raspberry Pi and modem manager, network manager, and all of that kind of fun stuff. All right, so let's unbox this here. Now, what's great about this particular modem? This is the Waveshare SIM7600G. Great little modem. First of all, global bands, that's very important. This will support, as far as I'm aware, all of the countries we're going to. Another nice thing about this, actually, let me take this out of the packaging. Another nice thing about this particular modem module is that, as you can see, it is Raspberry Pi Zero shaped, but also it has these little pogo pins. So normally a Raspberry Pi hat will connect to the GPIO pins of a Raspberry Pi, but the GPIO pins the GPIO pins do not have USB, and these modems need USB to transfer data. Normally, you just need to have a cable or some sort of adapter to connect to the USB port on a Raspberry Pi, but what's nice about this is the Pi Zero has these little test points, DPDM, as you can see right there, and those give us USB. So with these pogo pins, like those two right there, plus these two for power, basically just kind of, like this. This whole thing gets sandwiched together, and then we get a little Pi stack with the modem and a Pi Zero. Now, I designed this case without perfect dimensions in particular. I didn't really know what the height of the standoffs that we would be getting, so I'm hoping I guessed correctly. Otherwise, I'm just going to reprint. I'm going to have to reprint a new version anyway, because I've already made some changes. Oh, and also, you're probably wondering what this adapter is. This is micro USB. I don't want micro USB, so just pop that in there, and there you go. We get USB-C for power, and this whole thing drops right into the case, like that. The USB-C port is held in place. There you go. Now this whole thing's USB-C powered. Also in the box we get antennas that we will not be using because I will be ordering some flat flex PCB antennas that'll just be able to stick onto the sides of the case here. But for now, these are good enough. This is our LTE antenna with a little SMA connector, and then I believe here an IPEX, and also USB. Here we go, IPEX to SMA adapters. GPS ceramic antenna. Again, I'll be getting a smaller version of this. GPS not super necessary for this, but you know, we have the capability, might as well use it. And finally, the standoffs, and that's pretty much it. So I guess we are on our own at this point, or of course we can go look at the wiki, but I think I understand how to put this all together. Another nice feature about this modem card is that you've probably noticed it has these USB-A ports, and there's a little FE 1.1S USB 2.0 hub on there, so that is also very nice. Yes, USB cable. Since the other nice thing is that this modem can be used independently. You can just plug it into USB, and that'll be great for, you know, when I'm working on like Plasma Mobile or something, testing modem stack stuff on the desktop. All right, so let's open these standoffs. I have no idea what or how much of this I need to use. Now we need, as far as I understand, we got these short standoffs. These will go on the top / bottom. These will be going on this side of the Raspberry Pi. The entire Raspberry Pi will be sitting upside down like this in the case, and then screwed in from the bottom. One thing I am concerned about slightly is, I think I am correct in this assessment, which is that my heatsink might be a little bit, oh, you can't see that, might be a little too tall there. So I'm probably going to need to take that off, but we will cross that bridge when we get there. So as far as standoffs are concerned, I guess just to take these long standoffs, and I'll get that done for all 4 of them. Now, one thing I might have to do is pull out the soldering iron, since I have seen some reports that these pogo pins don't really do a good job, or actually do a job at all, of connecting to those pads, since you can probably tell they're slightly bigger than these pads. So I'll put it on first without doing any soldering, and then if I have to solder little blobs on there for the pogo pins to make contact to, I'll do that. And there we go. That is the little pie sandwich. I put this on backwards. Dang it. And there we go. We have our little pie sandwich of the modem and the Raspberry Pi. Very nice. You can see the 2 pogo pins for power and the 2 ones for data that touch onto the little test pads. Now the other moment of truth is if I put this with the adapter for power, if I put this in here, will the USB port line up? Was I correct? Hey, look at that. Oh, well, close enough. You know what? Good enough for oh, actually the whole Pi is slightly ajar. If I make it less ajar, slightly worse. All right, cool. So what did we learn? I was close-ish. It's actually very sideways. Oh, there you go. Yeah, I was off by a little bit, so I just need to nudge that hole over a little bit. Plus, the Pi actually sits quite far back in the case, so I actually might just make this hole even bigger. That way the kind of entire USB network adapter can kind of just sit in. Next thing I want to see is, did I get these holes to line up? Also, I am correct, the heatsink is in the way. I think what I might do, just because this is a prototype version, is just snip out these grills to let the heatsink sit flat. Yeah, I think that's the plan. There we go, and now the heatsink can just sort of stick through. Good enough to get us mounted. Another interesting thing to note, I was actually making this wall thicker in my 3D design, but actually this, you can kind of tell, yeah, you can see, this board is actually slightly wider than the Raspberry Pi Zero. I was thinking that the, it's very lucky that the SIM7600G module is the same size as the Pi Zero, but it's actually not. This whole board is slightly bigger, so I do have to keep that into account. Okay, so I think for now I'm just gonna go caseless, just because these holes that I made on the bottom are not quite big enough to fit. I mean, the one metal screw did fit, but my nylon M2.5s here are not good enough to thread through that, so we'll fix that once I get access to those other metal M2.5s, and then we should be good, and I can make these holes slightly bigger. So I've gotten the design modified a little bit here, and I've got that going with Tinkercad. There you go, and then pulled over into Ultimedia Cura. And we'll export this and send it to the 3D printer. But besides that, I think the fitment is pretty good, and of course we'll widen out the USB port. But I think it is time to get, I knocked the tripod. I think it is time to get this plugged in and see if we can actually get online with this modem. Also completely, actually no, kind of related, calipers, digital calipers, great. It's taken me way too long to finally buy one of these, so yeah, these are great. This is how I designed it. Well, I started off with the design someone else made for this particular hat, and then I modified it with the dimensions from this USB-C port and all that stuff, so very nice. Highly recommend a set of calipers if you're doing 3D printing and designing. Very useful. First things first, there should be a couple of LEDs, I think on the bottom or on the top. Either way, there should be a couple of LEDs on the module itself. So if we plug this into power, this should immediately light up. If it doesn't, that means I'm gonna have to do a little bit of soldering on those two pins just to give them little blobs that these pogo pins will have access to. So let's see. And the Pi is on, and hey, look at that! The modem is powered up. So I'm gonna unplug this very quickly before Raspberry Pi OS starts booting up. But perfect. So I don't have to do anything. It is getting power straight from those pads. I might still put solder on them just so they get good contact, since I don't know if I really trust this flat on flat action over here. These pogo pins are totally fine because that is a full kind of 2D surface, and they're little pokey, small pogo pins. But these are flat and wide. So, all right. So here's my Pixel 3 XL, and this phone I have a Lucky Mobile SIM card that I'll just be able to yoink out. Let's just pop that out. Now I actually don't know what size SIM slot this is, so let's hope it's nano SIM, which it does appear to be. That just there you go. It clicks right into place. So that is perfect. SIM card is now installed. All right, we should probably plug these antennas in as well. Let's plug this little Apex connector in. Never a fan of plugging these in. These are always so tiny and so fragile. All right, so that little pigtail connector is in. Very nerve-wracking every time doing that, and I will just screw on. There we go. The LTE antenna. This whole thing's very precarious, obviously. I won't bother with the GPS antenna for now. And I will put away the rest of the stuff, clean this all up, and we'll head to the screen capture, and let's see if we can get connected to the network. Okay, so I know you were expecting a screen capture, but for some reason the Pi decided to not want to connect to Ethernet, and I couldn't ping it, so instead, I just plugged in an HDMI, and we have the output here, and I just have a keyboard, so we can log in and just do it like this. All right, so we're getting some signs of life here. We have WWAN0, which is the modem, and then WLAN0 is the Wi-Fi chipset. So far, the modem is there, and in fact, if I do an LS USB, this very terrible keyboard. There we go. We have our Qualcomm SimTech modem showing up right there, as well as our hub. So now we should be able to use Modem Manager, MMCLI-L, I believe. There we go. There's our Qualcomm SimCom 7600G. So of course, SimCom is the manufacturer of this module, but underneath this module is actually a Qualcomm, I believe, like an X15 modem or X5, something like that. It's a category 4 LTE modem. I don't know if I've already mentioned that. So 150 down, 50 up. So yeah, there's actually basically an entire Raspberry Pi Zero built right into that module. There's RAM, and it runs Linux that's handling the actual modem, and then it's exposing itself over that USB interface over here. And in fact, also if we do a LS PTY USB, there we go. So these are all, I think all of them, or at least like 3 of them or 4 of them, supposes a serial interface for sending AT commands. If any of you are familiar with like dial-up modems, basically the same thing, AT and then a string of characters to send commands to the modem. And then there's another one for I think debug, one of them to send audio, and then there's something called QMI mode. QMI is basically Qualcomm's proprietary binary protocol, so rather than having these serial devices and AT commands, QMI mode gives us more direct access to the modem. Basically, QMI is if you have an Android phone with a Qualcomm chipset, or I guess even an iPhone with a Qualcomm chipset, since a lot of iPhones have modems, they're going to all talk QMI to their modem. And so this way we can talk more directly to the modem without having to go through this AT serial port layer. And it's totally alive. So I figured out the easiest way to get this to work was to use Network Manager CLI, adding a GSM interface, CDC WDM 0, which is the QMI interface for this modem, specifying the APN, and then you can see that created that GSM device, brought it up, got an IP address, and now we can ping the internet. So there we go. And I mean, that's a great ping for a modem as well. So there you go. This thing is totally working. And this is also with one antenna. So once we get the little flat, rigid antennas in the mail, I'll be able to use 2 of them. So we'll have theoretically the full Cat 4 LTE speed, as well as a small ceramic antenna. Yeah, this is looking up. I also have the new version of the case printing, so I've made some modifications. I've adjusted the sizing of the USB hole as well, and also some other changes. Like, for example, the walls were a little too thin to have the screw holes. As you can see, the wall didn't even generate or print there. There's just like a cutout where the screw holes themselves that was too thin. So I made the walls a little thicker around that area. But yeah, hopefully this should work out pretty well. Another day and another iteration of the case. Well, we have V1 of the case, we have V2 of the case, and it's time to print V3. Okay, using the power of my favorite soldering iron, the Pine Sill, I have successfully added 2 little solder blobs to the GPIO pins. That will hopefully allow better contact to those power pogo pins, since before, if I nudged the board slightly, it would lose power. So that should be a big improvement. So as you can probably tell by the change of scenery, I am back in Waterloo, and it's been a few days and a couple of developments. First of all, we got our LTE antennas in the mail. Now, I would have filmed this portion of the video yesterday, because of course here are the PCB antennas. Well, there's a couple things. First of all, they do fit in the places that I would want them, so one would stick right here. The other one should stick on the inside here, but I didn't really realize how thick these antennas would be. I actually assumed that these would be flat flex PCBs, not hard PCBs. So yeah, the next revision of this case, I'm gonna have to make a little bit more room so that I can actually slide in through there. The other more pressing issue though, is that this little connector here is actually the wrong connector. So they look similar, they look like they'll fit. However, this is where we have to get into terminology a little bit. These are IPEX connectors or U.FL. There's a whole bunch of names based on the manufacturer you get them from. The point is, this is a U.FL/IPEX1 connector. And the connector on here is actually an IPEX4 connector, which is a smaller and I guess newer generation of IPEX connector. So this will not actually fit onto this, and that is why I had to wait a little bit, because I have now gotten, this is a U.FL/IPEX1 male, female, I forget the distinction here. Anyway, the point is this is a adapter from IPEX1 to IPEX4, and this should fit on the board. So theoretically now we should be able to get this all hooked up. Now that I have one out here, you can sort of see what's happening. We have the female end here of the connector, and you can see how that is the correct size compared to the IPEX1 connector here. Yeah, the size difference is quite apparent. And then this other side is the, oh, there you go, the female connector. So this, theoretically, I guess the way we should do this is that we'll go down here, and it's gonna be a little finicky with the camera in the way, but I should be able to do that. This should theoretically plug into this. There we go, just like that. So that has snapped on. And now theoretically, this thinner cable should now be able to snap on to our Waveshare board. And there you go, just like that, we have our connector adapted. Now this is a pretty unfortunate amount of cable slack. Thankfully, I guess the the whole case is a little bit bigger, so I should be able to sort of wrap this around something like that and get that in there. Though for now, we'll just leave it hanging out like this, since this is all all temporary. We're gonna transplant this case anyway. But now for the kind of exciting part, well, sort of exciting part, is the fact that we now can put in the second antenna. So we plugged in the main antenna, but now we should be able to plug in the auxiliary antenna, which will give us the faster LTE speeds. So there you go, there's our second antenna. And I will do the exact same thing and get back to you guys. And there we go, both antennas are in. Now I'm curious, you know, how much loss there really is in this adapter. Hopefully not too much. So if you're wondering, this last connector here is the GNSS, aka GPS connector. I have an antenna coming that has not arrived yet. A little tiny ceramic antenna, and that'll go in there. But theoretically, we should be now good to plug this in to get the... Oh, also, I bought when I bought these antennas, they came as a 10 pack. So, you know, I guess I have more if I ever need that. Oh, also I threw some feet on the bottom just to see if those feet would work, since I bought a little pack of feet. So theoretically, I should be good to plug this in, and let's see what the performance is like, I guess. Oh, and also one of the great things, I love this USB-C cable. This is, you've probably seen these before. They're USB-C cables, but they have a little watt readout, so I can actually see how much power this is consuming. Also, this tells us, yeah, this works great with USB-C PD, I guess, the little adapter. Also, so far in my testing, this does seem to only take about 2 to 3 watts in general. I guess that'll go up to 4 or 5 probably when we're actually doing routing. We'll see. And there we go, it's working. So we're connected to the network. We have signal quality. This is probably fine. I didn't actually bring the other big antenna for reference here, so I assume this is about correct for this area. The cell service in this house is actually not very good, and this house has metal sidings as the wall, so it's kind of a big metal cage. I wonder if I can actually get more detailed signal quality measurements or modem manager. Should look into that, obviously, because some parts of this trip will be in relatively rural areas, especially as part of the Hokkaido part of the trip and the Alishan part of the trip in Japan and Taiwan, respectively. Both of those are going to be relatively rural in some of the places we'll be at. So it's important that our modem actually has decent RF performance, so that we can hopefully we'll get decent network connectivity while we're out there in the city, and in places like that. I have no doubt that this will work perfectly fine. So there's a saying that temporary solutions become permanent solutions, or something like that. Anyway, totally not related to any of this. Just to get a proof of concept going, I have secured the antennas here. I have the main antenna secured right to the side here, and then I just looped the cable around, the coax cable, and then I have the other one just mounted to the top here. Originally, obviously, it was going to go on the inside on this side, but that didn't fit. But it does fit perfectly fine if I strap it right to the top. In general, you just want it to be as far away as possible, so the antenna is here, and then this one is, on this side for spatial streams. Honestly, I have no idea. But anyway, I think this will work. The other thing you've probably noticed is I've used a little bit of electrical tape to tape together the IPEX 1 to 4 adapters, and that's going to hold them nicely in place. And the reason I did that is because I actually snapped one. You can see here this is the female side, and the male side actually came out as I was sort of fiddling with everything to see how things get placed. So these, very fragile. Good thing I have a pack of 10. I guess that's why they sell them in pack of 10s. In any case, this wire just sort of tucks in like so, and then the whole thing very carefully will close up, and it does fit. So I can now screw that screw in, and theoretically we have success. Now there is a little bit of even with the screw in, there's going to be a little bit of movement here because this is not perfectly designed, but if I'm not lazy, I'll make another iteration of the case. Okay, so quick update here. I have printed the 4th and hopefully final version of the bottom case. I've enlarged it slightly now so the antennas will clear on this side. And I have a brand new batch of antenna here that I've used heat shrink tubing, as you can see by my giant box of heat shrink tubing that has finally come to good use. There's just a little bit of heat shrink to hold the very delicate IPEX 1 to IPEX 4 adapters. So with that, hopefully this is going to be the final build. and then I'll come back to you guys with it all completed. And completed it now all is. So we're now back to the future. We're now in the future, back to the future. You know what? Never mind. Doesn't matter. The point is, I thought I will show you all the inside. So this is the lid, as you can see, nice and shiny. And this is the finished product. So I am quite happy with how this turned out. I think this is a very satisfying little piece of design work. Our main antenna is right here on this left side. We have the GPS antenna down there, also Beidou and GLONASS, Galileo, etc. And then just barely you can tell in the back there is the auxiliary receive antenna, which is what gives us the two spatial streams that allows this thing to go up to 150 megabits per second. And yeah, we get access to the nano SIM through this side, the USB port there, which I can use for hooking this up to Ethernet or anything like that. All very useful. There's access to the micro HDMI, nano HDMI, I don't quite remember. I think micro HDMI through there, so the whole cable can just stick in. That's great for debugging, and that's pretty much it in terms of the hardware. It's got little feet on it, and it just sits. There is no integrated battery. That is probably the one downside of this particular design. Now, my rationale for not putting a battery in is actually quite simple. It's that, while traveling, I'll be carrying a pretty beefy, this is a 10,000 milliamp hour portable battery along with us, and this thing doesn't really use that much power, so it's actually probably a lot more convenient to just have this be smaller without an integrated battery, and then use USB-C to power it with the power bank that you have along. Plus, this is not even the only power bank I'll be carrying around. My phone will be using this MagSafe power bank. So yeah, overall, I think that makes sense to just reduce the complexity of this project overall. Another just kind of random fun fact that you might be interested in is just be careful with these wires. So I have obviously the RF antennas. These two, the receive antenna and the GNSS antenna, are both just passive. They're just receiving. But this main antenna is also responsible for sending. So there's quite a bit of RF power coming off of this antenna. And when I originally put everything up into this case, I had this cable looped kind of down near the bottom of the case, right next to the USB pogo pins and power input of the Raspberry Pi. And with that cable down there, I was actually experiencing instability with the Raspberry Pi. I was having the modem randomly disappear off the USB bus or crash on the USB bus, or have the entire Raspberry Pi crash. And I eventually figured out that if I moved this wire up and away from that power input, it would actually stop. So that's something interesting to keep in mind. I'm not quite sure what's actually causing that problem. My guess is something about ground coupling and RF noise is causing something to be unhappy, in the CPU. There's not really a lot of power filtering on the Raspberry Pi Zero. It's quite a delicate device in general. So be mindful of where you route your RF cables. But yeah, besides that, that is the completed build. All that's really left now, I think, is I will show you guys the software setup. So originally, earlier on when I was testing, we were using Raspberry Pi OS, as you saw. But I've now installed OpenWRT on this, just to make the whole thing a little bit more reliable. And OpenWRT is pretty convenient, obviously, for this kind of thing, since it's designed to be run on wireless routers. So that's how I created the hotspot, as well as all the scripts for turning on the modem and sending the VPN. Other great thing is because we're going to be swapping SIM cards as we move between countries, OpenWRT just gives me a web interface that I can go in and set the APN for Modem Manager. That all just works out great. So next, let's go look at the OpenWRT setup, and I will get this all buttoned back up.
Okay, so let's talk about the software setup, because this is obviously what makes the FOSS spot the FOSS spot. So as you can see, we're running OpenWRT, and honestly, this part was super easy. I pretty much just used the built-in support for Raspberry Pi that's right into OpenWRT. I did use the image builder, which was kind of cool. I haven't used OpenWRT's image builder before, and that was just to integrate some of the packages. But other than that, it was pretty straightforward. The only thing is that on the Raspberry Pi 02W, the Wi-Fi firmware is not actually built into OpenWRT, so I had to go and grab that from a stock Raspberry Pi OS image, because the instructions that are on this page are not actually up to date for the latest revision. There's a revision of the Wi-Fi chipset on the Raspberry Pi 02Ws, but I just grabbed the firmware straight from Raspberry Pi OS. and that totally worked. And as far as that's concerned, I mean, we are a router. We have a Wi-Fi access point, obviously at the maximum 72 megabit speed with one stream of wireless N, but that's good enough for us. If we head over to interfaces, we can see the modem manager LTE WAN. Now, I have actually put the Japanese SIM card in here, so that is why this is showing up as unknown. But normally this would just come up with an IP address and IPv6, which is great. Adding the modem manager was really as simple as coming in here and adding a new interface with the type modem manager. So speaking of modem manager, there are actually two ways of doing modems in OpenWRT. There's the UQMI, I guess like OpenWRT native stack for running modems, or you can use modem manager. And as someone who likes messing around with Postmarket OS and Plasma Mobile and such, modem manager was the route I decided to go with. And yeah, it was actually really easy. You pretty much just install modem manager along with the kernel modules for QMI WWAN, as well as the WWAN serial ports. Also kind of interesting is it does use UCI for configuration. And then you just install the Lucy Proto Modem Manager package, which gives us the ability to create a modem manager interface inside OpenWRT. And if we look at the OpenWRT console, we can do it on mmcli-m0, and we get all of our modem manager information just like that. You can actually see I've already set the APN now for the Japanese SIM card, and you can see that the not connected to a network currently. But yeah, there really isn't that much else. I have just a couple of random packages. For example, this one package that gives me a power off button, the advanced reboot package. That one's quite nice. I also just did some other random things, like I used Nginx instead of UHTTPD, which is actually a thing you can do, and I was not aware of that. We have the performance. I thought I might as well. This does work on the latest version of OpenWRT as well. Now, the one thing I actually wanted to do here that I never actually got around to doing, but I might still do if I get some time, is I would like to do, well, two things. Number one is that by default, the OpenWRT image is quite small, so there's not a lot of storage space available on the disk since you have to go in and expand the SquashFS. It's kind of a whole thing. But if I get that done, one of the things I was actually planning on doing was setting up something like SyncThing or rsync or something like that to basically have a folder that is sunk with the Nextcloud that is holding all of the documents and tickets and things like that for the trip. Have that synced locally to this hotspot, and then run Samba, so that in the event we say have no data connection, we're out somewhere, there's no signal, but we need access to a ticket or something, we have that Samba share available locally. So that's something that I have not set up yet, but shouldn't be that hard to do once I've expanded the rootfs, and then basically just install Samba regularly with OpenWRT, as well as whatever syncing technology I want to go with. But yeah, performance is pretty good with this. Not amazing. Real world performance, if I have this plugged into Ethernet when testing, you get right about 30-ish megabits, maybe 35 megabits per second down, and like 40 megabits per second up, which again is fine for LTE use, since we're probably not going to be getting super fast anyway. Plus, the limit of this modem anyway is around 100 megabit. But it would have been nice to have something a little bit more performant. There is that USB port, which you can put a wireless network adapter in if you wanted, or you could potentially use a different single board computer instead of a Pi Zero that has a bit better Wi-Fi performance. But for my needs, the range and the speed was not really that pertinent of an issue. But yeah, other than that, that's basically the software setup. I just went in, flashed OpenWRT, installed Modem Manager, installed some packages. There's also this Gpoint package that I haven't gotten working on boot, but this does normally work. This pretty much just gives us a map of where the GPS location, and it pulls that from GPSD, which is listening on that serial port that has the EMEA data. But yeah, hopefully the next clip is going to be me in Japan out and testing the hotspot, or maybe it doesn't work. So I guess we'll see. That's the suspense. Why are you chewing his ear? What's up? So, ladies and gentlemen, we are here in beautiful Osaka City. It's been a few weeks. Say hello to carton developer Kenoi. This is going in the final video, by the way. So yeah, it's been a few weeks. We've been using the FOSS Spot. In fact, it is on me right now, and we even have OpenWRT, and it's been working great overall. So let me actually pull it out, and I'll show you guys a little bit more of that. And here we go. Here's proof. This is the FOSS Spot live at location in Osaka. So it's been pretty decent, and overall, I think it's been an improvement, at least over my normal LTE connection with my phone. The antennas have been working pretty good. The speeds, we've definitely been limited by the LTE speeds. We've definitely been limited by the speeds of the Raspberry Pi's built-in Wi-Fi. But other than that, the connection has been solid. I've been using it out and about like this. I've used it on the train, which has been pretty good. I didn't end up using it in Taiwan though, since we're only there for a few days. I didn't want to get another SIM card. But yeah, overall pretty good. The battery lasts pretty much all day, and plus some. Any last words from a carton developer? Yo, what's up, guys? It's Frank. Also, for those playing along at home, I guess if you, for posterity's sake, let's check out the status of the network. We bring up our cellular statistics here. And there we go. We're connected to M-Air, which is the I actually forgot the exact brand of SIM card that I bought, but yeah, it's on the Docomo network. And as you can see, I mean, right now where we're at, we're getting 100% signal strength, which is pretty good. Although I did a speed test just recently, and I was getting somewhere in the neighborhood of like 5 megabits down, which is obviously not amazing, but I was getting around 20 megabits up. So crowded areas do have some congestion issues with the speed, but overall it's been pretty good.
Hello, so I am back home, and I think it's now time to end this video soon. Shout out to you if you have made it all the way here. Anyway, before we go, I think we should do a quick post-mortem analysis of the FOSS Spot now that it's been run through its paces. Overall, I think this project was a success. There weren't really any showstoppers, and it performed basically as I thought it would. Battery life was not really a concern at all, though honestly an integrated battery would have been more convenient. Something to think about for V2. Signal strength was okay across the board, though there were some times where the FOSS Spot was connected but not my phone, so I guess we can just call that one even. Really, there are two main things that I would change if I had to do this again. One is probably around the form factor. It'd be nice if this was a little bit smaller and slimmer. Another thing is that I would definitely round off these corners a lot more. So this is quite sharp, these corners, and so it kind of made it annoying when I'm throwing it into like a tight bag or whatever, like the hip pack on myself. Another thing that I actually did not expect was that this thing got pretty hot, especially when it was operating in that hip pack, since it was in an enclosed space. It did get quite warm, enough that it was noticeable. I could feel it. That's definitely another thing to keep in mind in terms of making sure this thing has enough airflow, though I don't think it actually throttled or anything, so it's okay in that respect. Oh, also the feet fell off, so that's fun. I would definitely put little indents or something. But yeah, I mean, overall, I think it was a success. FOSS Spot worked, people used it, I used it, performed adequately. So I hope you enjoyed this video. This has definitely been a fun build for me. But yeah, make sure you like, subscribe, you know the drill, and definitely let me know in the comments if you have any ideas or improvements for the FOSS Spot. And of course, I'll be uploading the STL files and all of that to GitHub if you are interested in building one of these or something like this. But in any case, I'll see you guys in the next video. Goodbye.